All right. So in our last class, we talk about arithmetic, like sequence and series. That's what we are able to discuss in that class. And we said when we talk about sequence and series, we are simply talking about the succession of terms in such a way that the terms are related to one another in a way according to a well-defined rule. So that was what we are able to discuss in the last class as far as this is concerned. So in today's class, we are going to continue from where we stopped. If you remember, we stop at the nth term of an AP. Am I right?
Yes, sir.
Yeah, we stop at nth term of an AP. So today we are going to go to the sum of an AP. The sum of an AP. And here, I quickly want to explain something, although I've said it in that class. I told you that when I say addition, somebody say addition. And when somebody says sum, these two things, they are quite different. Are you getting this now? But because of the level we are in learning, we tend to use them interchangeably. If I say series, when I was explaining series in the last class, I tell you that if you have an arithmetic sequence, that it is, let's say, 1, 2, 3, 4, 5, 6, and so on like this. This is an arithmetic sequence. You got to see that it is an AP, right? But that's not what I want to explain. I want to explain sequence and series so that I'll be able to explain the difference between addition and sum for you guys. Now, if you look at 1, 2, 3, 4, 5, and 6, this is a sequence now because they have common difference. It's a sequence, or they have a specific rule that bind them together. So it's a sequence. But I differentiate between one term and the other using the comma. Abi?
Yes, sir.
So because differentiation is with comma, that is what makes it a sequence or a progression. But if I change it and I use plus in place of the comma that I'm using, I use plus in place of the comma. This is a series, because a series is defined as the addition or subtraction of individual terms in a sequence. So if you look at this now, I only add together. I didn't give you what the total number is. This addition here is more or less like the comma. But if I've said that find the sum of this sequence, it means that I will have to add 1 and 2, then 3, then 4, then 5, then 6. And I'll be able to come up with what? Their sum. Are you guys following?
Yes, sir.
So you can see that the difference between addition and sum is clear now. When I say addition of a number, you are talking about what? Putting an algebraic sign, which is plus, in the midst of those numbers. Not you writing down their exact value. But when they say sum of a number, you're talking about what? Adding them together and put out the exact value. I believe you understand that the difference now.
Yes,
Yes,
sir.
sir.
All
Yes.
right. So in today's class, what we want to look at is sum of sequence. And what sequence are we talking about? We are talking about AP. That's the sequence we want to look at, the addition now. How to add the terms in AP together. Because, if I give you something like this is an AP now. 1, 2, 3, 4. Let me change this. Let me change my pen to white. Okay. So watch. If I have 1, 2, 3, 4, 5, 6, and I said find the sum of the first four term. You can easily find that by saying 1 plus 2 plus 3 plus 4 equal 1 plus 2 is 3, Abi. Then that's 10. Isn't it?
Yes.
Now, this is very easy to do because number one, you can see the term you want to add together. Number two, is not much. But let me now ask you, let me tell you that find the sum of the first 100 term of this sequence. You know, that will be a bit difficult for you to do. Find the sum of the 100th term. You can't start writing from 1 to 100 and you now start 1 plus 2 plus 3 plus 4 plus 5. So for that reason, there is need for us to be able to generate something that will make this kind of easy for us to do. So if that should be the case, take down this, write down. Sum of terms in AP. Sum of terms in AP. Sum of terms in AP. Are we there?
Yes, sir.
Right.
Yes, sir.
Right. The sum of terms in any AP. The sum of terms in any AP is the addition of the sum of terms in any AP is the addition of all the terms involved in a particular AP. Full stop. Now, let us now take for instance that the given AP is let's say the AP that we are talking about now, we want to generalize now. Let's say the AP we are talking about is given as A plus the second term, that is A plus D, plus the next term, A plus 2D. Or let me put it like this. Let me generate the AP like this. Excuse me, please. Okay, so let's say this is the AP. Then the next term is going to be A plus 2D. Then the next term is going to be A plus 3D. Then and so on like that, down to where A plus N minus 1 times D. I see this now.
Yes, sir.
Now, if this is the given AP, if what you have on the screen is the given AP, let the sum, we want to calculate for the sum. We say let Sn represent the sum of the AP, represents the sum of the AP, represent the sum of the AP. So we are letting Sn be the sum of the AP now. So if that should be the case, that means that Sn is equal to A plus, open a bracket, A plus D, the bracket, plus A plus 2D plus A plus 3D plus dot down to where plus A plus N minus 1 times D. Where are the sum of the AP now? We have added the whole of the term together. Abi? Now,
Yes.
if you remember, when we are talking about the nth term of an AP, we are able to note that T of N, that is nth term, of an AP is given as what? A plus n minus 1 times D.
D.
Okay.
Yes, sir. Yes, sir.
Now, if we are now looking for, remember this is equation 1 now. Now let's now take for instance that we wish to find the sum of Sn, that is this particular one, of an AP, I guess, with n numbers of terms. That is, the numbers of terms there, it is what? N. It means that we are going to be having S sub n to equal to into brackets A plus n, guys, open a bracket here, A plus n minus 1 times D, then close the bracket, plus another one will now be, I did the first term now, then the second term is now going to be plus n minus 2 D, then we have A plus n minus 3 D, and then plus, we just have it like this till we have plus A plus D times plus A. So we are taking this in the reverse order now.
What is up?
Look at the first equation here and the second equation here. What am I saying? Sorry, this is the first equation here. Here is the first equation and here is the second equation. Are we following?
Yes, sir. Yes, sir.
The first equation is not in terms of n. The second equation, we are expressing what? Each term in terms of n. Are we following now?
Yes, sir.
Okay.
Yes, sir.
All right. So if we add the two equations together, that is, you add equation 1 and 2 together, you are going to be having Sn plus Sn. That will be 2Sn. Following.
Yes, sir. Yes.
And then that will give us 2A plus n minus 1 times D in bracket plus 2A plus n minus 1 times D, and so on like that. So let me put dot 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 plus 2A plus n minus 1 times D. So this is what we are going to have now. We now look at this. You get to see that what is common here, if we are to factorize out.
Yeah.
If you keep on adding all of these together, you get to see that they are the same thing, isn't it?
Yes, sir.
Let's say let's take for instance that the numbers of terms in this sequence that I added together, it is 3. That makes that this one will become 3 into bracket 2A plus n minus 1 times D. That will be the sum of everything here, isn't it?
Yes, sir.
But remember we said it,
Yes, sir.
but remember at the beginning we said it is what? Nth term. So we let the numbers of sequence there to be n. So if the numbers of sequence there is what? Is n now, therefore we are going to be having 2n, the 2 sub 2Sn equal n multiplied by 2a plus n minus 1 d. Then we'll close this. Have you seen this now?
Yes, sir.
Now quickly take this down before I clean it. Quickly take it down before I clean it.
Sir, please, I'm not seeing it too. Your name is blocking it on the screen.
Yes, sir. The simple. Same here.
What's blocking the screen?
Yes.
Sir, your name.
Which name?
Which name?
His name, like the two
Sir,
S
like
and one not
that
seeing it here.
left bottom, like the left bottom side. There's no, like your name is showing there, and it's blocking what you have written.
Can you see what I want? What I'm bracketing now?
Yes, sir. Yes, sir.
Can you see all of this thing I circled?
Yes, sir.
Then what's there that you don't see? You've seen the whole of the screen, huh?
Sir, you don't understand. Like there's. Sir, I'm sorry to say this, but Adejumo Toyib is blocking this, like from this place.
That's your own screen now. Work on your own now.
And the two S is blocking that two S plus
Yeah, exactly.
that side.
That should be from your Telegram. It's not from my own side.
Tap on the screen.
Are you
There's no name there.
Tap on the screen. You
there's
see
no-
two big clear.
okay, sir? No worries, sir. I've seen it. I've seen it.
You know,
Sorry, sir.
okay, right fast, please.
Okay. I've seen.
So are we done?
Yes, sir.
No, sir. No, sir. No, sir. No, sir. So I'm not true. Oh, no.
All right. So from here now, the last thing we have is that 2s sub n equal n into bracket 2a plus into bracket n minus 1d, then close the bracket. Abi? So what we are looking for is Sn. And for us to get Sn, what are we going to do?
So divide through by 2.
So we'll divide both sides by 2. So we have this 2a plus n minus 1 times d. So this is what we're going to have now. So this is going to be the sum of arithmetic regression. So this is sum of AP. You get this formula clear now?
Yes, sir.
Now, I want you to understand something now. If you look at this particular formula very well, you get to see that I can rewrite this formula. I can rewrite this formula as this. I can write this formula as this. S sub n equal n over 2 into brackets a plus n minus 1 times d. Do you all agree with me?
Yes, sir.
Now,
Yes, sir.
if you look at this, now, you guys will see that a plus into bracket n minus 1 close the bracket d is the nth term of solving what is it called? Solving for AP. This is the nth term of an AP. A plus n minus 1 times d, Abi. So
Yes, sir.
it means I can rewrite this as Sn equal n over 2 into bracket a plus
A plus A.
t sub n. Now.
Yes, sir.
So if t sub n is the last term of the sequence, if t sub n is the last term of the sequence, then the sum of the sequence is equal to n over 2 into bracket a plus the last term. So it means that if you are given a sequence that you know the last term and you are asked to find the sum of the term in that sequence, you can just use what? This equation. I'll take it again. So you can use this particular equation if you know the last term in a sequence. Why you use this if you don't know the last term in the sequence? Let me give you an instance. If I have 1, 2, 3, 4, 5. Are you seeing this now? And I give you 1, 2, 3, 4, 5, and dot dot dot. Are you seeing this now? If the question says find the sum of this sequence, find the sum of this sequence. What's the last term of this sequence?
5.
So since you already know the last
5.
term, since you know the last term of the sequence now, it means this
5.
is the yeah, I've gotten that. So this means that this is the equation to use since you know what the last term of the sequence. But if you don't know the last term of the sequence, let's say I say, what's the last term of this particular sequence here? This second sequence, what's the last term?
Is unknown.
The last term is unknown, Abi, because it is an infinite sequence. Now, if you are asked to find the sum of, let's say, the 6th term, or find the sum of the 7th term, so since you don't know the last term of this particular sequence, you make use of what? This first equation. Do you understand that now?
Yes, sir.
Quickly take it down, and let's take example.
Yeah.
Can we?
Yes, sir.
All right.
Yes.
All right, let's move forward now. So, let me close the board. Now, let's take example 1. For example 1, are you there?
Yes, sir.
So take down. Find the sum of the first 25. Find the sum of first 25 terms of the sequence 11, 15, 19, 23, and 27. Dot, dot, dot. Now, if you look at this question, the first thing you want to check, if you look at it, I want you to understand how to attempt questions under sequence and series now. You look at this question very well. You get to see that the question does not state if it is AP or GP. Abi?
Yes, sir.
But
Yes, sir.
but we already know that it's going
Yes,
to
sir.
be AP because we are dealing with some of AP, right? But let's
Yes.
take for instance that it is random question that we don't know if it's going to be AP or GP. Whenever you are given a question under sequence and series, the first thing you want to test is to know the kind of what sequence that it is. Is it AP or GP or harmonic sequence? Although for your level, you might not be dealing with what harmonic sequence. You mostly deal with AP and GP. So you need to check first. Is this AP
Yes.
or GP? And how do you check? Look for their common difference. The second term minus the first term, that will be 15 minus 11. Abi?
Minus 11.
And that will
Yes.
give us 4. Now let's check. We can also find the common difference by saying the third term minus the second term. That's 19 minus 15. What's our result?
4.
4. Since
Four.
since it has been established that they are having common difference of 4, and when a sequence has a common difference, it's referred to as what?
An AP.
An AP. So definitely the question shows that this is an AP. Now, the next thing you now need to ask is that what is the first term of this AP? What's the first term here?
11.
11.
Write it down. 11. The next question you want to ask yourself is that the sum of how many terms are we looking for?
The first 25.
So n,
First 25.
so it means that n is going to be 25.
Yes, sir.
Now, the third question, which is the last question you want to ask yourself, is that is this a sequence that is infinite or a finite sequence?
Infinite.
Infinite. And you know that looking for sum of infinite sequence of an AP is given as Sn equal n over 2 into brackets a plus 2a.
Plus
2a.
2a plus
A
into bracket n minus 1 times d.
close bracket D.
So do you get this now?
Yes, sir.
This is the formula we are using. Therefore, the sum of 25th term is going to equal 25 divided by 2 into bracket 2 multiplied by 11, then plus 25 minus 1 multiplied by what? 4.
4.
Then we'll close the bracket. So the sum of the 25th term is now going to be, so 25 divided by 2. Let's still leave it like that because it's still going to give us fraction. So let's still leave it as 25 over 2. So don't let us deal with fraction. 2 times 11. 22 plus 24 times 4. Now, before you go on, come. This is mathematics, not further mathematics. So you need to write this step that 24 into bracket 4.
4.
Do you get that now? But mathematics,
Yes,
further
sir.
mathematics, you don't even need to go through all this next step. You can just jump to your answer. That's further math for you. But mathematics, you have to show the step one after the other. Is that taken out? So,
Yes, sir.
the sum of the 25th term is now going to be 25 over 2 into bracket 22 plus 22 times 4.
96.
96. So you now have what? S25 equal 25 over 2. 22 plus 96.
118.
1 what?
18.
118. Abi?
Yes, sir. Yes, sir.
So here 1, 2 in 118 will give us what?
9.
59. So for that reason, we have that S25 rather. S25 equal 25 times 59. What will our result like that?
147.
1475.
75.
So that's the sum of the 25th term of that sequence. Do you understand that now?
Yes, sir. Yes.
Take it down. Let's move on.
Battery is low already. 8%.
Okay, sir.
Okay. Let's take another question now. Question 2.
Shall we do?
Are you still writing?
Yes, sir.
All right. Write fast, please. Okay, take down the second question. So while he's writing, take down the second question. Okay.
Yes, sir.
Okay. Put it down. The 9th and the 22nd terms of an AP. The 9th and 22nd terms of an AP.
Some true.
Okay. 9th and 22nd term of an AP. The 9th and 22nd term of an AP are 29, 29 and 55 respectively. Stop. Find the sum. Find the sum of its 60th term. Find the sum of its first. Find the sum of its first 60th term. Find the sum of its first 60 terms. Are we there? So can we go on?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
All right, guys. So can we go on now?
Yes.
Now, how do we undo this question? If you look at this now, you get to see that it's quite different. It's quite different from what we had earlier. This question is not direct. And this,
Yes,
this
sir.
class is just like an interactive class. You should understand that question will not always come directly like you have the formula. You should be able to think out of the box. Every question that they will be asking you after you've learned something, know that that question will always come back to test what you've learned. So if you look at this question, we are now told that the 9th and 22nd term of an AP are 29 and 55 respectively. Find the sum of its 60th term. Now, of its 60 terms rather. Now, for the sake of those that want to approach this question directly, let's approach it directly and see where we are going to stop, and maybe that will let us understand what we have to think about. Now, the first thing we have to check, we are already told, we don't need to check it again. We have been told it is what?
An AP.
It is an AP, so we don't need to check that again. The second thing is that the first term, do we know the first term?
No.
No, question mark. The second thing, how many numbers of time, what's the common difference rather?
I'm not given.
We are not given. So, what's the next thing we have to write? The numbers of time we are looking. So we know that that's 60, Abby?
Yes, sir.
Now, what again do they give us in the equation? They give us T9. And our T9 is what? 29.
Okay.
They also what? Managed to give us T22. And then that's what? 55.
55.
Now, how can we now find this unknown? Because the formula we want to use is that Sn equal n over 2 into bracket 2a plus n minus 1 times d, close bracket. This simply means that the whole of the thing that can enable us to solve this equation, we don't have them. We only have one out of what? Out of 4. Sorry, we only have one out of 3. So how can we find those 3? Let's come back to what we are given. Recall that the nth term of an AP is given as what? A plus n minus 1 times d. Are you seeing this now?
Yes, sir.
So we already have the 9th term. That is, the 9th term of the sequence is equal to A, we don't know, plus, since it is the 9th term, we know it's going to be 8 of the common difference, isn't it?
Yes, sir.
And this equal to 29.
9.
So let's call this equation 1. Then we go for T22. That's the second thing given to us. So that will be A plus
A plus
21D
20.
equal what? 55.
55.
That's equation 2. Am I making sense?
Yes, sir.
Right. So if this should be the case, we can solve this simultaneously, isn't it?
Yes, sir.
And since the coefficient of A and A is the same, so we can use what method?
Elimination.
Elimination, correct. So we say subtract equation 1 from 2.
From 2.
So you have to subtract equation 1 from 2. So that will be this one will cancel, Abi. So
Yes. Yes.
21 minus 8.
That is 11.
11, Abi?
Yes, sir.
Are you sure it's
That's
11?
13. 13.
So that's what? 30.
Yes.
So we have 13D equal 55 minus 29.
26.
So we have 26. That simply means that D is equal to 26 over 13, and that's equal to 2.
2.
We have gotten the common difference, isn't it?
Yes. Yes.
Now take it down so that we can find the first term now. Quickly take it down.
True, sir.
Okay. Are we all through?
Sir, please.
Sir, please wait. I'm not done.
All right. So let's move on now. You said what?
I'm true.
All right. So since we have the common difference now to be what? To be 2. Let's now put the value of this common difference into one of these equations. So I will say put the value of D. Put the value of D. Don't worry, you see it clearly now. Put the value of D into equation 1. And what is equation 1? Equation 1 is what? A plus 8D equal 29. So that's equation 1. Abi?
Yes, sir.
So since D is equal to 2, so we have that A plus 8 into bracket 2 is equal to 29. For that reason, A is equal to 29 minus 16. And that will give us what?
13.
13, right?
Yes, sir.
So I've been able to get the whole thing that can help us to find the equation now. So the sum now. So N is equal to 60. And then A equal to 13. And then D equal to 2. Am I right? So the sum of the 60th term is going to be what? Why am I saying 60th? The sum of the 60th term is going to be what? 60 divided by 2 into A, which is the 13, plus, since the 60, we're going to be having 60 minus 1, right? That is 60 minus 1 times D, which is 2. And that's it. So S of 60 equal to 2 here 1, 2 here is 30. So we have 30 into 13 plus 59 times 2. 59 times 2. And then we have 30 into bracket 13 plus 59 times 2 will give us what?
118.
1.
18.
So we have 118 plus 13. I think we have.
That's
I think
131.
we have mixed something here. Just observe now.
Yes.
So there is 2 here.
Okay.
It's supposed to be 2
Yeah.
times 13. That is 26.
2 times 13. Yes, guys.
I've seen that.
26 plus
Come.
1.
So so we have what? 26 plus 118. And that will give us 30 into bracket. 26 plus 118.
144.
144. Times 30, what do you have?
That's 4,320.
4,320.
Yes, sir.
So that's our solution to the question. Do you understand that now?
Yes, sir.
So kindly Okay, so kindly take that down fast and try this exercise. Take it down fast.
True, sir.
All right. Shall we go on?
Yes, sir.
All right. Quickly, try this. Try this before we go on to the next one. Try this. Just a few minutes to answer that. Are we there?
Yes, sir. Yes, sir.
The 11th term of an AP. The sum of 11th term of an AP the sum of 11th, it's not 11, it's supposed to be 11. Sorry, please. The sum of 11 terms an AP is 891. Find the 28th. Find the 28th and 45th terms if the common difference is, that's question 1. Question 2, the sum of 8 terms of an AP is 160. Now the sum of 20th sum of the 20 terms is 880. Find figure 1, the 43rd term. Figure 2,
43rd. Yes.
43rd. Look at the screen. 43rd term. Figure 2, the sum of 12 terms. So your time starts now. So when you talk about arithmetic sequence, or what we can, I say arithmetic sequence, geometric sequence, what we can call exponential sequence, is a sequence in which any two consecutive terms differ by a constant, multiple, or factor. Let me take it again. Geometric sequence is a sequence in which any two consecutive terms differ by multiple of constant factor.
Differ.
Yeah, differ by a constant multiple or factor. Are you there?
Yes, sir.
This factor is called common ratio. This factor is called common ratio.
Differ by any.
Differed by a constant multiple or factor. A constant multiple or factor. This factor is known as common ratio. So let's see an example of that. If I have 6, 18, 54, 162, and so on like that. Or I have 16, 24, 54, 81, and so on like that. Or I have 20 minus 10, 5 minus 2 whole number 1 over 2, 1 whole number 1 over 4, and so on like that. Now, if you look at the first sequence there, if you say 18 minus 6, your result is going to be what? Is anybody there with me?
Yes, sir.
If
12.
That will be
Yes,
12. That will be 12.
I don't hear the question.
If I say 54 minus 18, how am I going to have?
42.
42.
36.
36.
Okay,
Yeah.
yes.
You get to see that the value is not the same thing, Abi.
Yes, sir.
Yes, sir.
That's to tell you that this sequence is not an AP.
AP. GP.
But let's check. If I said 18 divided by 6,
3. That is 3.
that's 3, Abi.
3.
Yes,
If
sir.
I said 54 divided by 18,
3.
3.
that's to tell you that the common ratio here, that's to tell you that the common ratio here is 3.
3.
Yes, sir.
So we say,
Yes, sir.
okay, so we say common ratio is 3. And here, this is 24 minus 16, and let's go 8, Abi.
Yes, sir. Yes, sir.
36 minus 24, that will be 12.
12.
12.
It's not the same thing, Abi.
Yes, sir.
Yes, sir.
That's to tell you that what? That sequence is not what?
It's not
It's not AP. So let's check if it is GP. That will be 24 divided by 16. That will give us what? 4 here 4, Abi. 4 here 6. That will be 3 over 2, Abi.
1.5.
Yes, sir.
And then let's check 36 over 24. This will give us 4 here
Same
will
3
give
over
us same 3 over 2.
3
Abi.
over 2. Yes, sir.
So you can see that the common ratio here is what?
3 over 2.
The common ratio is 3 over 2. And for the next one here, you see minus 10 over 20. That will give us minus 1 over 2.
1 over 2.
And this will be,
Yes, sir.
for the second one, we have 5 over minus 10. That will still be minus 1 over 2, Abi.
Yes.
Yes, sir.
So the common ratio
Is minus 1/2.
Minus 1/2.
common ratio is minus 1/2. Do you get this now? So
Yes, sir.
that's how you check for common ratio. So do you understand that? So take it down. Take it down. Let's move on to the nth term of a GP. Are we there?
Yes, sir.
All right. So now let's look at this now. We want to look at the nth term of a GP. For us to be able to get the nth term of a GP, the nth term that we are looking for is the general formula to find what? An unknown term. That is the term that we don't know how to find them. That's what the nth term formula is meant for. So how do we go about it? Let's take, for instance, we know that first term is written with A, Abby.
Yes, sir.
Let's use this first sequence as a guide. So first term is 6.
6.
And if you look at the second one, that is what? A, Abby. So let me take it like this. Sorry. So that I have a better understanding of what I'm trying to do there. Okay, so watch now. If I have Tn, that will be T1 equal to what? Equal to 6, and we can call it what? A, Abby.
Yes, sir.
The second term is T2, and that's equal to 18, which we can split as 3 times what?
3 times 6.
3 times 6. Okay, let me write it like this. 6 times 3. And that will give us, the 3 here is what? Common ratio for this, Abby?
Yes,
Yes,
So
sir.
we'll write it as AR. Then the third term, that will be 54, Abby. Okay.
Yes, sir.
Can we write 54 in terms of multiple of 6? That's times 9, right?
times 9.
6 times
Yes.
9.
Okay, I can write this 6 times 9, and that will just become AR squared, because 9 can be written as 3 raised to power 2, Abby.
Yes.
And T4,
Yes, sir.
our T4 is 162, Abby.
Yes, sir.
That is 6 times 27, Abby.
Yes, sir.
And that can be written as AR raised to power 3.
Wow.
Look at something, just to see that the power of the common ratio, or what do you observe there? Let me ask. What do you observe about
The common ratio is the same.
their common ratio will be the same before, because they are sequenced. What do you observe between the numbers of term and the power of the common ratio?
Sir, as the term is increasing, the number of the ratio is decreasing by 1.
Okay, you're not constructing it well. If you look at it, as the term is increasing, the power of the common ratio is also increasing. Can you see? At this point, it is R raised to power 0. At this point, it's R raised to power 1. At this point, it's 2. At this point, it's 3. So as the n is increasing, this one is also increasing. So what you said now is not going to be correct. So what do you think is happening? Maybe you should construct your statement.
Sir, the term is 1 less than the power of the ratio.
The term what? The power of the ratio is 1 less than the numbers of the term. So
number of 10.
So we can conclude that the nth term of a GP is given as AR n raised to power minus 1.
by n minus 1.
So this is the formula for the nth term of a GP. So you can take it down. Quickly take it down, please.
Right.
So take down the solution.
Yes, sir.
So
Yes.
let's another example now.
Okay, sir.
Okay, the second example now. Second example states that the eighth term of GP is 640. Full stop. If the first term is 5, find the common ratio and the 10th term. So are we there?
Yes, sir.
So the common ratio and
The
The
10th
10th
term.
okay.
Are we going?
Yes, sir.
sir.
All right. So let's look at the solution there. If I have the nth to be what? 8.
8.
And then we have that the 8th term is what's it called? 640. So that means that the T8 is 640, and the first term is 5. And we are asked to look for what? Common ratio and the 10th term. How do you go about that? We recall that Tn equal to AR n raised to power minus AR raised to power n minus 1. So Tn, which is T8, is going to be what? 860, sorry, 640.
640.
I know.
What are those now? So this is 640. Then the first term is what? 5. I mean, and the common ratio R is given as 5. I didn't write it. No, that's what we're looking for, Abi.
Yes, I'm looking for R.
It's minus 1. Abi.
Yes, sir.
Yes, sir.
So one, let's divide both side by 5 first. So
So I
Siki,
don't see what you are doing.
you're not seeing now?
So please, are you writing it?
Yes, I'm writing it.
So I was still seeing the last example here.
That should be that your network is lagging.
Yes, sir.
That should be network. How we going?
Okay, sir.
Yes,
Yes, sir.
sir.
640 divided by 5. What do you have?
128.
128.
So we have 128 equal R raised to power 7. So what can be raised to power of 7 that the answer is going to be 128? What can be raised to power 7?
Two.
Okay, so we have that 2 raised to power 7 equal R raised to power 7. So when power and power are equal, what happens?
You cancel it.
So base and base would also be equal. So the common ratio is 2. And since we now since we know the common ratio to be 2, then the 10th term of the sequence is going to equal a10 minus 1. So the T10 is going to be, what's our A? Our A is 5. Then our common ratio is 2. So 5 times 2 raised to power 10 minus 1. So the 10th term of the sequence is going to equal to 5 times 2 raised to power 9. So what's 2 raised to power 9? 2 raised to power 9 is what?
512.
5 times 512, what do you have?
That is 2,560.
2,550.
Yes, sir.
And that's the 10th term of the sequence. So I've been able to solve that now.
560.
You said?
2,560.
560.
Yes, sir.
Yes, sir.
I thought you said 550. All right, so I've correct that. 2,560. So you can take it down and then we dictate the assignments, then we'll call it a day. Take down the assignments now. Out there. Find the 6th term. I'm dictating it. Find. Okay. Can you guys hear me?
Yes, sir.
Yes, sir.
Take down the assignment now. Number 1. Find the 6th and 7th term of the AP. Find the 6th and 15th term. Find the 6th and 15th term of the AP whose first term is 6 and common difference is 7. First term is 6 and common difference is 7. Number 2. The third term of an AP is 10. The third term of an AP is 10 more than the first term. The third term of an AP is 10 more than the first term. While the fifth term is 15 more than the second term.
Sir, please come again.
The third term of an AP is 10 more than the first term. Is 10 more than the first term. While the fifth term is 15 more than the second term. Is 15 more than the second term. Find the sum of the 8th and 15th term. Find the sum. Find the sum of the 8th and 15th terms of the AP. Out there?
Yes, sir.
If the seventh term is 7 times the fourth term, if the seventh term is 7 times more than the first term, number 3,
More than the first term.
yeah, number 3, and that will be the last one. Given that are you guys there?
Yes, sir.
Given that 4 comma x comma y comma 4 comma 972 dot is a geometric sequence. Find the sum of x and y. Find the sum of x and y. I think that's a very good place for us to stop. So if you watch the video, don't forget to like, share the video, and subscribe. Have a nice day.